Okay, sorry about that drop there. So we're going to have q times that a prime times y prime we talked about up here. So for that, it's about this area here above the neutral axis. So it's going to be width of 5 times 100, and then it's going to be times that y bar. And this y bar, I'm going to do a bit of better drawing of that here. I'm just doing the smaller section, and then I'm going to draw the neutral axis in red here, and A. So this is going to be a changing value, and it's going to go from the top down, and we're going to call this a variable s. So in order to get that, we know the full distance of that half is 100, so that's awesome. But then we need the centroid of that, so it's always going to be changing, so we just know it's going to be s over 2. A neat way to think about it, based on how far down it's gone. So if it's gone down like maybe just a couple, it'd be 100 minus whatever s over 2 is, so it would be higher up. So let's say it only went down 1 from the top, so the value of s is 1, and then minus s over 2, 1 over 2, so really that would be, we'd have that 100 minus 0.5 s over 2, and then it would be 99.5 from the distance of the neutral axis up. That would be that centroid. So enough about that. When you multiply that out, what you'll end up getting is, I believe it's 16.67s minus, I think it's 0.08 times 10 to the 3, but I just want to make sure I have it correct. Oh no, sorry, it's something completely different. I'm getting ahead of myself. It's 500s minus 5 over 2s squared. So this guy kind of getting busy, so we'll make a new one. But 760 Hibbler, and remember we had I equals, what do we have I as? 30 times 10 to the 6 millimeters. And then we have our new Q as 500s minus 5 over 2 s squared. So from here, we go back to that, we're solving for Q basically. So we go Q equals V, which ends up being P times this Q value, 500s minus 5 over 2 s squared. And then that's all over 30 times 10 to the 6. And multiply that all out. A good way to do it is just divide the 30 times 10 to the 6 by the 500s and by the 5 over 2s. So you'll get Q equals, please, P times 16.6 times 10 to the negative 6 s minus 0.08 3 times 10 to the negative 6 s squared. Okay, so from before, remember we're solving, trying to find this E value, and we want that fx. So to get that fx, because we just got q, that's q, sweet, we need to integrate q to get fx. Not a big deal, actually. And I don't know about you, but I don't like integrating funky numbers like these, so we can simplify that by pulling this value right here, this 0.083 and the 10 to the negative 6 out and drop it in here. So if you divide that by itself and divide that by 0.083, you'll get q equals 0.083 times 10 to the negative 6 times 200 s minus s squared. Much easier to integrate. So let's integrate q. That should be on that side. So when we integrate this, there should be a p there. Because p is a constant, this is a constant, we can pull both of these out on the other side of the integral. So we will get integral 0.083 times 10 to the negative 6 p time, and then in here 200s, there should be a dx here, all apologies, dx. So if I can find my handy dandy Inspire, I already calculated this out. Oh, and I gave away a big tip. So we're integrating, and we're integrating over an area, and our area was 200 total there, but we're going over that neutral axis. So this area here is only that 100. Oh my goodness, 100 millimeters. Why don't I just draw that thing again? So 100 millimeters here, 100 millimeters here, and we already drew our S section from this zone. So we're going from 0 to 100, but we're doing it on both sides. So what that means is we're going to go from 0 to 100, but we're going to do it twice. So we're going to multiply everything we get by 2. So when I plugged that into my graphic calculator, I ended up getting 0.11 p. Great. So we now have that q. We solved for this fx equals q. So now we go back to that original E equation. Fx, we have it. D, we have it. And P, we also have it. Oops. P, we have that. And so that is 0.11 P times, what is that, D? Depth was 300 over P. P's cancel. 0.11 times 300 is 33. I shouldn't have had to look at my calculator for that, but that's okay. And that's millimeters. Yeah, that's shear center. That's not bad. It took me 20 minutes, but I say a lot, so it should take you less time without me. Good luck.